I think we've got everyone is joined there. I see the numbers staying steady. So, guys, just to mention that Aoife today is going to be introducing our host today, Declan, and managing the Q&A. Aoife is working with EWB this summer as an intern. So I'm going to pass over to Aoife now, who will introduce the webinar today, and we hope you enjoy it. Thanks, guys.
Okay, so we'll start off the webinar now. Firstly, thanks to everyone for joining us on the third episode of the Resilience webinar series. Today's webinar will be presented by Declan Alcock, and Declan is a chartered engineer and a director at EWB Ireland, director of the Irish Green Building Council and project director at Farming Consulting Engineer. He has 20 years experience working in building service consultancy and sustainable building design, so we're delighted to have him on the webinar. And Declan will be presenting on green building, the new normal for people and planet. So before I hand you over to Declan, I just want to mention that we will have a Q&A session at the end of the webinar. So if you have any questions you'd like to ask Declan, just message in the chat letting us know you have a question. And once Declan has finished his presentation, we can unmute each person to allow them to ask their question. So thanks very much, and I'll now pass you over to Declan.
Thanks very much, Aoife. So you're all very welcome along episode 3 of our webinar series. We've had some really good ones so far with Liam and Conal, so hopefully we'll continue in that light. So as Aoife mentioned, I'm going to speak about green buildings. It's something I've been working with for years. As an overview of it, I suppose there's been really big unprecedented challenges for society and the planet in general over the last few months. There's also been very significant environmental gains. It's sort of a silver lining, I suppose, of the whole situation. For anyone who doesn't know me, I'm, as Aoife said, I work with Farming Consulting Engineers as a project director for sustainability, director of the EWB and director of the Irish Green Building Council. As you can see, COVID has had an impact. So one of us looks like an imposter. I'm not sure which one it is. This is part of a wider EU project that we're working on. We've 14 partners in 7 countries. The project has been going on for 3 years. And it's really to increase public awareness, facilitate critical understanding, and promote active engagement towards achieving UN SDG 11. Which is to make cities and human settlements resilient, inclusive, safe, and sustainable. SDG 11 has an impact on a lot of the other sustainable development goals as well. We'll see that later. So, as I mentioned in the news, we've seen a lot of the environmental gains out of what's been happening, a really bad situation over the last few months. We've seen in Venice, anyone who's been there, the canals are noted for being particularly polluted. So we've had wildlife coming back there from a reduction in human activity. We've even had foxes appearing on Grafton Street, which you don't see very often. But an eye-opener for me, anyone who's lived in Kathmandu or visited Kathmandu, this is a view that wouldn't be familiar to very many people. Under the arrow there is the summit of Mount Everest, 200 kilometers away. And it's probably the first time, definitely in decades if not generations, that Everest has been visible from the Kathmandu Valley, which is 200 kilometers away. To see it, what the Kathmandu Valley normally looks like, that's it. So that's a very stark indication of the impact on air quality, and the environmental impact that's happened. So you can see it from this graph, there's been a significant reduction in global emissions, something around 17%. You can also see that even the recent financial crisis, anytime there's a global crisis, reduction happens in emissions, but it also bounces back pretty quickly. And that's because people just go back to normal. We go back to the way we used to do things. And if we go back to the way we used to do things, we'll just get the same old results. While it's understandable with all the challenges, people want to go back to normal social interaction. in a bigger picture, we know that the frequency of disease and the risk of pandemic is linked to climate change and biodiversity loss. The degradation of natural systems brings human and animals into closer contact, increasing the risk further. So the summary of today really is, do we want to go back to normal? Or should we build on the gains we've had over the last while and move forward and try and build a more resilient future? The big issue in Europe, we're talking about resilience in this webinar series, and it is a huge issue in Europe in terms of energy security. So we import about 53% of our fuel. A lot of it is fossil fuel. To build a bit of resilience and energy security there are really two options. One is transition away from that to renewable energy, and the other is reduce the energy demand to begin with. Realistically, we have to do both of them. An indicator of progress, I suppose, with the transition to renewable energy. These figures are a few years old, but 19.5% of energy for heating and cooling, for example, in the EU was from renewable sources in 2017. In Ireland, pretty feeble, 6.9%. So that hasn't been going very well. It hasn't been going very quickly, or definitely not quickly enough. To reduce demand, the big win here is the building sector. It's the most significant energy sector in the EU. Well-known figures there, 40% of energy consumption comes from the building sector, and it's been recognized at COP21 a few years ago that it's the most economically beneficial path to reducing global emissions. And there are also numerous economic, social, and environmental benefits from it. A lot of people, when they think about energy usage or CO2 emissions, they think about, for example, in your house, the level of insulation, what your utility bills are like. You might have some solar panels on your roof or whatever. The picture on the left there is global CO2 emissions by sector. And we can see that while operational is certainly a factor in it, there's embodied carbon is often an overlooked element of it. If we look at this building life cycle, really operational, as I said, is small. It starts off with extraction of materials. It goes to manufacturing of products. It eventually gets to the construction site. Obviously, you have plant equipment, people traveling to and from site there as well. Then the building is in operation. So you've use, you repair, maintenance, replacement. Eventually it gets demolished and then disposed of in landfill or recycled. So that's a very linear process. And all along the way there, you also have transport. You have to transport those raw materials to the manufacturing plant, transport them to the site, transport them to recycling or disposal. So if we look at it that way, operational is a very small element of it. Embodied carbon, which is sometimes overlooked, is actually quite significant. And going back to Kathmandu for a second, the air quality issues there, you can see a lot of it has got to do with two factors: transport, but also manufacture of materials. These are really inefficient coal-fired brick kilns that are used to manufacture bricks because of the expansion of the city. It's a very stark indication of the impact of manufacturing in the building sector on air quality. We spoke there about briefly about SDG 11, and while I suppose a lot of people think about it in terms of housing, there are a lot of other elements underpinning it. We're talking about transport, air quality, green public spaces, and climate change. And these are all elements where green building can assist. So for those of you who aren't really aware, and there are lots of different terms, there's green building, I suppose passive building, sustainable building, they all pretty much mean the same thing. This is the World Green Building Council, I suppose, definition of green building. So during the design, construction and operation, it reduces or eliminates negative impacts and can create positive impacts on both the climate and natural environment. How it does it: efficient use of energy, water and resources, use of renewable energy, reduction of pollution and waste, enabling of reuse and recycle. And that is, as I said, it's a linear process typically. It really needs to go circular and more starting and ending with reuse and recycle. Good indoor environments, use of materials that are ethical and sustainable and non-toxic. And a design that enables changes, adaptation to the changing environment, particularly now with climate change, with a warming environment. That's very important. So to summarize it, it's really, it's about people and planet. Green building thinks of both of them in design, construction and operation. A lot of the principles between sustainable design or green building are not new. We've been dealing with them for centuries. In different parts of the world, under different climate conditions, different types of buildings developed, and it was mostly by trial and error. It was about using the materials that were locally available to hand, to, I suppose, use the beneficial aspects of climate and mitigate against the worst extremes of climate, whether it's hot or cold or whatever. The same thing happened in Ireland here, happened all over the world, different climate conditions. So if we look at a cold climate, first of all, I suppose, the top one is in Scandinavia, the lower one is in Ladakh, in the Himalaya, which is recently in the news. And they have certain attributes in common. So the priority here really is conserving heat. It's the main thing, and utilizing solar gains as well. Typically, they're positioned either with embankments, maybe on the sheltered side of a hill. That protects against cold winds. Trees are also used for south-facing orientation to use solar radiation. Buildings tend to be very compact. For example, low ceilings. You want to keep the heat in the habitable zone. And compact and large buildings can also be compact. It's a definition of the surface volume to area ratio. And green roofs, a lot of times they can be sort of turf roofs to help with insulation as well, retain heat. And local materials, for example, if you look in Scandinavia, it's timber. Pretty common material there. It's good for insulation. It's a low thermal or high thermal resistance. In the mountains, you're above the tree line. So obviously timber isn't as useful as building material, so they might use ram dirt. That can also soak up heat during the day, provides a buffer against the cold night air. If we look at hot climates, similar thing, use of local materials. Obviously, the main feature of design here is protecting against intense heat and solar radiation. So because there's a very large swing in temperature, very hot during the day, cold at night, typically in a desert climate, use thermal mass that absorbs the heat during the day, keeps the internal areas a little bit more comfortable. And then when it is cold at night, it releases the heat. A lot of shading. Buildings are constructed close together, so they overshade each other. And then social spaces like streets as well they're accessible to people because they're in the shade during the day. Small windows, because the sun is so intense, it's going to provide adequate daylight as well, and it's trying to limit hot air getting into the buildings. And the use of separate ventilation openings and stacked ventilation. But these are all items that are common in building design today. One really interesting, and it'd be called innovative today, is in Iran, the use of wind towers, wind catchers. And this was centuries before. It was like the 1700s. Older ones have been found from the 1600s. And centuries before people used advanced simulation modeling like we have now. And really impressive way of getting around in a desert climate using natural ventilation. So I mentioned a few common things here, and these were people designing buildings today. would use the same principles. So using local materials, or at least materials that are appropriate to the climate, optimizing orientation, solar radiation, shading, using daylight, natural ventilation, insulation. So all about energy use and building for the location rather than a generic type of building. And we seem to have somewhere along the line transitioned to this. No matter what climate you go to, whether it's hot, cold, humid, you'll find concrete buildings with lots of air conditioning. It's just build them highly serviced to deal with the climate. So maybe we need to simplify building design and get back to first principles. In terms of green building, there are a huge amount of benefits for them. We're not going to go through all of them, very limited on time today, but we'll show some examples. For example, the urban heat island effect. Because of the amount of concrete, asphalt, etc. used in cities, and it absorbs solar radiation, it can actually cause a 4-degree temperature difference between a city and surrounding countryside. And this is going to become more of an issue as the climate warms. Everyone is probably familiar, or most familiar, with green roofs. A big issue in the EU and probably worldwide is the fact 75% of our buildings, our existing buildings, are inefficient. So it can provide a certain amount of insulation, which is useful for reducing air conditioning or cooling requirement in the summer, and also heating requirement in the winter. It can humidify the surrounding air, provide a little bit cooler, and also a certain amount of reflectance of solar gains. Living walls, not so I suppose, popular in Ireland at the moment, but they are used quite a bit around the world. So they've been used for reducing traffic noise, for example. There's not a lot of research into it, but one paper I read said it reduced by about 15 decibels, or about half the amount that double glazing would reduce it by. It could also be used for food production. For example, if ground space is limited, there's a lot of surface area there to work with. And this is probably the best example of it. It's probably the most photographed, I suppose, building in the world at the moment as well. Or has been over the last few years, really a flagship green building project. This is Bosco Verticale in Milan. So 2 residential towers, 800 trees, 4,500 shrubs, and 15,000 plants over the surface area of this, or on the balconies and whatever. And this exhibits a lot of the benefits, I suppose, that we were talking about there. So all this greenery absorbs pollution from traffic, from whatever you have in the city. It also produces oxygen and improves the air quality. Because it provides shading, it keeps the building cooler during the summer, so less requirement for cooling, and provides a buffer against cold air in the winter, so less heating energy. It provides a whole, I suppose, urban ecosystem for wildlife, for birds, and also obviously reduces the heat island effect. The same architect, and I suppose it's a step up. What about rather than a vertical forest city? This is a master plan for a city in China, also by Stefano Guerri Architects. An issue which, and it's been recognized with this building as well, it's a challenge rather, is the amount of concrete required as a high embodied carbon. They did, in the previous example, they did try and optimize that, reduce it, by reducing the weight of even the planters on the balconies, using specialized soils in the planters to reduce it, cut down on the requirement for concrete. They also use heat pump technology to reduce the energy, and solar pumped groundwater for irrigation rather than potable water. But the next big movement, I think, is going to be to get away, or at least reduce that impact. And I know the cement industry has been, there are some companies, one Irish company in particular, that's at the forefront of reducing the environmental impact of cement. This is a new sort of movement, I suppose, in green building design. The tallest timber building in the world is in Norway at the moment, 18 stories. And these are master plans, concepts for buildings in Tokyo, Canada, and London. So that's going to be another big movement in green building to tackle the embodied carbon. So that was the outside of the building. If we move inside now, we've all obviously been spending a lot of time indoors recently, more than normal. But when things were, I suppose, pre-COVID, people would typically spend about 90% of their time in a building, whether mostly at home and at work or at college or whatever. Temperature, lighting and air quality have a big impact on health and well-being. You can see on the right there, this is from the World Green Building Council as well. In terms of business and the business case for green building, energy is only about 1%. The potential saving on 90% of businesses' costs are got to do with people. So if you can improve the health and well-being of your staff, they're more productive, they're happier, more content with their job, it can have a huge impact. And to put it simply, from a work environment, would you feel more content or happier in working somewhere like this or working somewhere like that? It's got to do with people's connection with nature, got to do with light, good air quality, and overall comfort. So as I said, the environment impacts your experience of a workplace, and that has economic implications for a business. And it's based around biophilic design. So there are three aspects of it. I suppose the main point of it is you're bringing that experience of nature indoors rather than relegating it to parks and the outdoors. But even if people want to relax, they'll generally go for a walk in the park, go to a hillside. It's that natural human connection with nature. Given the time, we won't go deeply into this, but there's the direct experiences like light, air, water, plants, indirect experiences, like even natural materials. And there's been recent guidance got to do with COVID and the potential for, I suppose, transmission through ventilation systems. So there is recommendations now to increase the amount of natural ventilation in workspaces. In schools, very important learning environment, obviously for kids, it's a very formative part of their lives. Research has shown improvements in good, well-daylit spaces with good air quality, and even people who have a view. So it could also potentially, and this is important in COVID as well, because of the proximity of people in classrooms, it has been shown to reduce allergies, asthmas, and transmission of other respiratory diseases. And again, given COVID and the I suppose focus on healthcare these days, going back even as far as the 1800s, it was recognised that healing gardens and green spaces had a beneficial effect on patients. In terms of the EU, we spend a ridiculous amount of money on healthcare. So if people can recover quicker, spend less time in hospitals, that is a knock-on effect of reducing the pressure on public health systems, has a financial effect as well. And the same for staff and visitors. Obviously, it's a very pressurized environment. This is a wonderful example of a hospital in Singapore. So if you can reduce those pressures or give some release from it for staff, it's obviously beneficial. And visitors as well, visiting hospital, a worrying time for people. So anything that can make people feel calmer, more relaxed. The final slide on this part of it is the big challenge. We don't have time to go into this today. It would be a separate webinar, but the European Green Deal has recognised that there needs to be a renovation wave around Europe. It's one thing designing new buildings that can be efficient, but 75% of existing buildings are very inefficient. And 80% of those buildings will still be in use in 2050. So that's a huge amount of energy usage, embodied energy as well. And there's a very limited amount of renovation happening at the moment, something like 1% of buildings a year. So that's the next wave. It's a story for another day, but it's going to be a huge challenge. So if I was to leave you with three takeaways from today, one is keep it in the ground. It's in my opinion anyway, there's no valid argument for using fossil fuels in buildings anymore. I mentioned SDG 11 and its impact on other SDGs, so briefly I'll try and illustrate that here. But really we need to transition to renewable energy and do it a lot more quickly than we're doing it. We also need to transition to a zero carbon built environment. That's also been slow. There's been nearly zero. There's, you know, incremental movements. It needs to happen a lot quicker, and it has an impact on society, industry, on economic growth, the green economy. It has an impact on several areas of society. So that needs to happen a lot quicker. And the final one is we have to remember that buildings are for people, not robots. As you look, the example of the two offices, the days of the sectioned off little workspaces, I think are long gone. We need to make buildings more amenable to people for their well-being and their satisfaction. This is from my son, Arthur, who's going to be 2 next month. A few weeks ago he was playing, and this was his attempt at building a house. And it really struck me. No preconceived notions about houses or how they should be built. So I asked him why he put the trees on the roof, and he said it was for the bumblebees. So if this is obvious to a less than 2-year-old, I don't think there's any excuse for the rest of us who are apparently professionals. I'm just going to play one last video here for you. We'll finish up with this. It's a project. It's okay looking at slides, but I suppose an example of how we're trying to increase resilience in a community. It's with 2 partners, Habitat for Humanity and Zambia, Ireland. It's a project they're doing in Zambia that we're very proud to be involved with. And it'll illustrate it, I hope, a little bit better than slides. So it's only a few minutes long. If you have any questions, obviously, we'll take them directly after this. Okay, so that's the end of the video. Does anyone have any questions?
So we have a question from Josephine.
Yep.
I will just unmute her now. Okay, Josephine should be able to speak there now and ask Declan your question.
I think it's still muted there.
Okay. So I think Josephine just wants to say thanks for the presentation, Declan, and she really enjoyed it.
No problem. Or if people want to even type them in, it's fine as well.
So we actually have a question from Bert Holmes, so I'll just allow him to speak.
Hello.
Hey, how you doing?
Yes, I'm good. Okay, so I have this quick question. I'm a postgraduate student at DKIT, but I'm very much interested in the activities that you are doing, and I was just thinking beyond just building, the aspect of integrated development that can look at issues of energy, water, and other things. So I'm looking at how possible to be a part of this team and to bring on board my bit of experience in this field of community development, energy and water resource management and other things, so that at the end of the day, buildings or engineering works that will be given out to such communities will help in achieving all the SDG goals, basically 6, 7, 11, and 12, if I may say.
It's how best to go about it.
Yeah.
There's lots of ways of doing it. I think you could join EWB on our website. There would be one way and get involved in our work. In a professional way, the SDGs are not about, you know, big aid agencies. They're about everyone, communities, individuals getting involved. So you could do it in your normal daily life. It has just as big an impact as you know, doing it with an organization, or even in your working life. Just to be conscious of reducing waste, being more efficient, and using resources effectively. It's, I suppose, a misconception about the SDGs that it's all about massive aid agencies and governments, but it's not. It's about everyone, every individual doing their part.
Okay, that sounds quite good. So I will look at the website and also try to see if there's a way.
Yeah,
Get
absolutely.
Membership or something. Or
email us if you send it, if you want to more information and get in touch through the website. Definitely, I'd be happy to help you out.
All right, thank you.
No problem at all.
So we have another question from Patrick.
Hello.
Yep, how you doing?
Yeah, I was just interested with regard to the existing housing stock in Ireland and the fact you said we're going to stuck with 80% of it. What do you believe we should prioritise there with respect to reducing energy consumption? What's proven to be the most effective? You know, is it insulation?
It completely depends on the building. There's no one size fits all for renovation. It completely depends on the building, because even using insulation, some old buildings, it will actually cause more problems than it solves. It can cause, you know, structural issues with moisture in the walls and things like that. So it depends on the age of the building, materials that were originally used. There's so many aspects to it.
And government policy in this area, do you think there's a lot of scope for improvement?
Huge amount. I'll be diplomatic about it, but there's a huge amount of scope for improvement. If you get in touch, actually, as I said, I'm involved with Irish Green Building Council as well, and they've been doing fantastic work with. There was a build upon project, and they've done other work in trying to upskill the workforce for renovation, and upskilling is a big issue. And it's quality control, it's about getting the right skills and that understanding that not everything can be fixed in the same way. I definitely recommend it if you're not familiar with the LGBC to check out their website, and they've got some excellent webinars as well on the subject. But yeah, I'd like to be more specific, but it really comes down to, as I said, the individual buildings, the type of building, how old it is, what it was originally constructed.
So, I suppose I'm interested to know but is it, what are the barriers specifically? Is it the cost? Is it the skills force? Is it understanding knowledge within the wider?
It's a combination of lots of things. Cost comes into it. There are some grants available. Upskilling of the workforce, certainly, because there are different skills needed. It's not just, you know, an engineer telling you need X, Y, and Z. And it's also raising awareness among building owners as well, that what they actually need. It's very easy for a company to say, oh, you need insulation, you need, you know, solar panels, you need whatever. So the average homeowner, they're sort of going on someone's word on that. So there's a lot to be said for upskilling homeowners. It's just a basic knowledge of it. They don't have to be hugely technical. To give them an appreciation of it as well. So the upskilling part goes right through from the homeowner right up to the professional, and everyone in between.
Thank you.
Probably.
So unless anyone has any other questions, okay, so that concludes today's episode of the webinar series. So thanks to Declan for his presentation and just a bit of information. So next week's episode will be with Colin Keogh, and Colin is a mechanical and innovation engineer and co-founder of the Rapid Foundation Sapient Innovation and Team OSV. His presentation will be on low tech for high impact applied technologies for local resilience. So thanks again for everyone joining us this afternoon, and thank you, Declan.
Thanks very much.